Inma, good morning.
Good morning, sir. Good morning. Happy Raja.
Happy Raja. Raja disturb bolwa.
ନାଇଁ ସାର୍ ଆପଣ ତ ଏଇଠି ଅଛନ୍ତି।
ମୁଁ ଅଫିସ ପଳେଇ ଆସିବି। ମୁଁ ଅଫିସ ପଳେଇ ଆସିଛି, କାଲି ବି ଆସିବି। ନ ଆସିଲେ ହଉନି ନା। ଘରେ ନେଟ୍ ଫେଟ୍ କଣ ପ୍ରୋବ୍ଲେମ ହବ କଣ ନାହିଁ।
ହଁ ସରି ନେଟ୍ ବାବଦରେ actually ମୁଁ ଘରେ ଅଛି। So I hope ମୋ ଜିଓ ତ ଠିକ ଠାକ ଅଛି।
ହଁ ହଁ।
Once ଯଦି ପାୱାର କଟ୍ ହେଲା ତାହେଲେ
ଭିଡିଓ ବନ୍ଦ କରି
ମୋବାଇଲ
କର।
ସରି
ମୋବାଇଲ କରିବ, ଭିଡିଓ ଅଫ୍ କରି କରିବ।
ନାଇଁ ଭିଡିଓ ଅଫ୍ କଲେ ବି ଯଦି ପାୱାର କଟ୍ ହେଲା ତାହେଲେ ତ ଜିଓ ତ ମୁଁ କଟିଯିବ ଭାରି ସେ ଫାଇबर କେବୁଲ।
So accordingly we'll
ଦ୍ୱିତୀୟରେ ହେଲା
inform to the students.
ମୋବାଇଲ ଉପରେ ଟିକେ ଠିକ ସେ ଆସୁନି। But try କରିବା।
So let us wait for another 5 to 7 minutes. At 10:05, 10:07 we'll start. Let all join. Chinmay sir, we can start. I think already 10:07, already 70 participants have joined, so we can start. Later they will join.
Yeah, sure. Okay, so let me take few minutes. Okay, so I hope I'm audible enough over there.
Yes, audible.
And yes. So let me first share the screen. Okay, I hope you can also see my screen. So over here, yeah. So good morning, everyone. And so today we'll be discussing CI/CD using GitLab. This is the session 3. So last time we discussed version control system, how you manage your software piece, your code. And then we discussed how you can containerize your application so that you can deploy that one anywhere, wherever you want, without worrying about the underlying infrastructure. So, so today what we'll discuss is how you can deploy your application, taking your different context or different situation into account and different requirement into account. So what we'll do today is we'll discuss what is CI/CD first of all. For example, what is continuous integration, what is continuous delivery, what is continuous deployment, and then we'll discuss what are the different tools for CI/CD. Of course, like before that, we need to understand what is the motivation behind CI/CD. Then what are the different tools, what are the different benefits, goal, all those things we'll discuss. And then you'll see how you can, the moment you write your software code and you push that one to your GitHub or GitLab, suddenly that code will be built, that code will be tested, and it will be deployed on the production environment. And that is something today we'll see in the demonstration also. So CI/CD, it's basically the CI is the acronym for continuous integration. So it's difficult to understand why it is continuous, why not it's simply just integration. What is the reason or what is the feature that enable or that allows the integration to be continuous? Then CD, which is usually a continuous delivery or continuous deployment. So when it comes to the continuous delivery and deployment of the software piece means when you as a company or as a team, once you are ready with the code, once you are ready with the software application, then you deliver that one your client, right? So once you deliver that one to your client, then you go to the client on site and then you deploy the application in their production environment. But what happens if the entire business itself is also developing the software component in-house? Then in that case, of course, you are not delivering to the external entity, rather you are delivering to the internal entity. So for example, like if let us take any example of social media, your Facebook or Instagram or WhatsApp or TikTok or Twitter or X. So what they usually do, they will develop the code, they will deploy in their own production environment. But what is the purpose of, or what is the meaning of the term continuous is very crucial. Uh, so continuous is mostly, if you look at how usually this continuous integration work. So here usually like what you do, you write your code on your local machine. For example, like yesterday, what we are doing, and then you run the local unit test. That means if you are writing, let us say 5 or 10 functions, then you basically test each and every functions, you test each and every files or programs, and then once you are satisfied with the testing, then you commit that one to your remote repository. So the remote repository, it could be your GitHub or it could be GitLab or it could be somewhere else, but you commit that one. So once you commit, that means the changes are right now in the remote repository. Now in the remote repository, again, you build the code, you run the unit test, um, of course, on the new code changes, and definitely after that you go for a advanced level of integration, other integrations. For example, integrating the new piece of code with other modules, and then testing whether the integration is working or not. For example, if you have modified the payment system, then you need to look at whether that payment system, or you need to test whether that payment system will work properly with the buying button, or whether it is working properly with the delivery options, or whether it is working properly with the wallet options. So obviously, in a larger system, you have multiple different modules are there. So once you develop one module, after that you need to check whether that module is properly working with other modules or not. So if you look at this workflow, someone like you maintain the single source of repository, you build it automatically. For example, like the moment you commit, automatically you don't have to again click on somewhere else to to build and run the further integration testing. Instead of that, you just commit your code and automatically that will be built and that will be tested. And obviously, when you test at the time, it's not just you are testing um, in a very some sort of like testing area. Rather, it's the environment which is pretty much mimicking the behavior or mimicking the characteristics of the production environment. So that testing area or that testing environment is something similar to the production environment, but obviously it will differ in some sense. For example, the size. In the production environment, you might have thousands of different servers, but in the testing area or in the testing environment, you don't need to have like thousands of different servers. Rather, you need to have probably 5, 10 servers, and on top of that, you test your new piece of code. So, uh, so when it comes to the continuous, the CD, so which is like continuous deployment. So when you say continuous deployment, it means like um, the moment the new piece of code is tested on the remote repository, and tested, it means it needs to go through a lot of different types of functional and non-functional testing. for example, like integration testing, system testing, load testing, um, unit testing, obviously, and then your user acceptance testing, your disaster recovery testing, and your compatibility testing. So your piece of code needs to go through a lot of different types of testing. And once it is tested from each and every stages, then it will go for the deployment. So from the testing to the deployment, if there is no human intervention, then usually it is referred to as the continuous deployment. Of course, once it is tested, once it is deployed, again the testing will be done. It's not testing, rather it is the monitoring will be done, checking that whether this new piece of code is not affecting the other existing code or other existing modules. So, so that is what your continuous deployment is all about. And everything should happen automatically. So when you need to do automatically, that means you need to have a right set of tool stack in place so that each and every tool can communicate with each other, and each and every tool uh, can understand their input or their output. So, so what are the advantages of this CI/CD? Obviously, there is a fewer handoff, uh, because the less of handoff mechanism. It means like um, once the development team is ready with a new piece of code, and they don't have to hand over that one manually to the testing team. Rather, it's a continuous process, and lesser the number of handoffs, more secure it would be, more reliable it would be, and more error free it will be. So from the security point of view, it's very much consistent in a way that you can implement your you can implement your security features from the very beginning, from the in terms of in an automated way. This will also increase the development speed. For example, like if there is no, I mean, if there is no waiting time, or if there is no hand of time from the development team to the testing team and to the operation team, then obviously that will basically save a lot of time. And when you save a lot of time, that means you focus more on the development and the deployment of your code. So with this continuous deployment, sometimes the applications or the companies, they are able to deploy different versions of your applications. Sometimes it may go up to like one deployment in every 1 hour. So before it was like multiple number of for each deployment, and the company then need to wait multiple number. Now they can deploy multiple number of or multiple versions of your application code in a in an hour. And again, because of this automation, you have a fewer or faster testing process, because you are not actually going and clicking on some button to test it. Rather, the moment you upload the code, it will automatically be tested. This is something like we'll see in the demonstration time. And obviously, it will be less bugs, because at the end, everything is scripted. What test needs to be done, um, in which order it needs to be done, in which environment, what test needs to be done. Everything is already scripted. So obviously, that will give a lesser chance of any bug. And these are also a few other advantages. For example, improved compliances, reduce the overhead spending, and the consistency process, because of uh, this automated script, which is applicable to all the environments. So now then question arises that what are the different tools that are available in the market? One of them is GitLab. So Circle CI is another one, which is also popular one. Jenkins is also another very popular one in terms of this CI/CD. But what we'll do today is we'll mostly focus on GitLab. So how you can deploy your application securely uh, how you can develop and deploy your application securely through GitLab. So GitLab itself, it gives a complete package. It's a whole ecosystem where it's not just to host your application code, but also test it, build it, and deploy it. And in addition to that, of course, you will have the container registry. So the container registry, if you recall yesterday's session, the Docker Hub. So this is something you're similar to that. It's the Docker Hub of GitLab uh, repositories. Also, GitLab allows you to manage the users, write the wiki for the project, write the CI. This is the continuous integration file, configuration file. And also it provides a lot of other features. So this is a bigger picture. This provides you an ecosystem, how to develop and deploy your application code on the production environment. So now coming to what is GitLab CI/CD. Obviously, we are not going to focus on. We'll have a brief discussion on this container registry. We'll not discuss the issue boards. We'll not discuss the user management, wiki, time tracker, Mattermost, and other integrations. Because our main focus will be CI, the continuous integration. So let us see what is this continuous integration. Uh, so if you look at over here, there are 4 different components are there. One is your GitLab registry. So this is where your Dockers and containers will be there. The other one is your GitLab CI/CD pipeline. And then you'll have some runner, shared runner, and then private runner. We'll discuss what are these runners. So in the CI/CD pipeline, so the pipeline, it's a YML file simply. The name always is fixed, GitLab-ci.yml. So this is always fixed, and this should be always, you need to keep it inside your project root directory. We'll see also in the demonstration. And in this file, we will mention that how to integrate the code, how to test it, how to build it, and how to deploy it. And everything all the instructions need to be mentioned in this CI file. So the GitLab-ci.yml. So sometimes it is also referred as simply CI file or the CI config file. Okay, and this is one example of a GitLab CI file. So some variables are there, some stages are there, build and run, and some jobs. So these are some sort of like some jobs, some tasks are there. How to run. For that um, we have different tasks are there. So it's basically like you have a lot of different scripts, and through those scripts, what you will do, you will build the code and will deploy the code. So GitLab registry, again, this is similar to your Docker Hub as you just discussed before. And then runner is, it's basically a small software tool. So the runner is basically responsible for running the jobs specified in the GitLab CI file. So in the GitLab CI file, so build Docker image. So this is one job. Run Docker image. This is another job. So we mentioned that one in the CI file, but who will run all these things? For that, you have which will basically go through each and every task one after another, and then it will run. But where are those, or where is that runner? So the runner can be inside your laptop. It can be in your production environment. It can be inside the GitLab itself. It can be probably wherever you want to deploy. Over there, your runner will be there. You need to install your runner over there. And uh, the private runner is something kind of is somewhere inside your laptop or inside your PC or inside your virtual machine. So today we'll discuss that. We'll see in a demo time that how to install this runner on your laptop, and then how to deploy uh, the Flash application on your laptop. without you being actually deploying the software code. So, and then what is the CI/CD pipeline? So if you look at the pipeline, it's just a group of different jobs. And then those jobs are, of course, specified in an order. So you also need to mention that what is the order of jobs execution. So for example, in the previous one, so this is one job, this is another job. It doesn't matter which job is written first and which job is written second. Irrespective of that, the the order of stages will basically decide which job will be executed first and which one will be after that. So for example, over here we have two jobs, so two stages, build and run, and first job will run inside in build stage, and second job will execute inside this run stage. So obviously the first job will be executed first, and then the second one will execute second. So all jobs in the stage are executed in parallel. So inside one job, so for example over here, inside build, if let us say if you have two different jobs, and those are belongs to one stage, that means all the jobs will run in parallel. Obviously, if all the jobs succeed, then the pipeline moves to the next stage. So for example, over here, build stage and inside build, probably you will have two different jobs. And once both of them are finished, then only the runner will check what is the next stage and what are the different jobs in the next stage. So for example, over here, build A, build B, these are two different jobs. Once those are finished, then it will go to the test stage. Test A and test B, both jobs will finish, and then it will go to deploy A and deploy B jobs. So, but what will happen if one job fail? So even if test A fail, irrespective of the result of test B, the runner will stop over here, and it will not proceed to the next stage. So obviously, you can explicitly mention and you can explicitly instruct GitLab that if a very specific test or a very specific job fail, then still you move on to the next stage. But that is something like you need to explicitly mention that one. So once you log into the GitLab, so to note here that yesterday we were managing the code in GitHub, but today we'll do that one in GitLab. Obviously, if you are comfortable with GitHub, then GitLab is also no big difference. It's again the same. So it will not take a lot of time to switch from GitHub to GitLab. Of course, in GitHub, uh, you don't have any concepts of group in GitHub, but at the same time in GitLab, you don't have any concept of organization, unlike GitHub. So in GitHub, you have organization. In GitLab, you have group. So those are like different terms are there, different concepts are there, but overall, the basic idea is same. So this is a screenshot. So once you go to your project, your GitLab project, you can go to your CI/CD and then you can click on the pipeline. From the pipeline, you would be able to see the list of pipelines. So the list of pipeline, if you look at the pipeline ID, so 5589, 5588, 5587, 86, 85. So these are different IDs are there. But if you look at the stage, so in this pipeline, there are like two different stages are there. So it's not, I mean, if you click on those tick mark, then you will see that what is the stage. But you know that, okay, in one pipeline, you have, in this example, there are like two different stages are there. So the tick mark over here, it means that the runner was able to execute all the tasks, all the scripts inside that job or inside that stage. The slash mark, this will basically say that it's a cancelled. The cross mark, it will basically say that there is an error. So we'll see all of them in the demo time. So if you click on the pipeline ID, then you'll see in the pipeline ID, you'll see when it was triggered. Then you'll see that how many jobs are there in that pipeline. You'll also see what the different stages, for example, over here, build and run. So inside build, you have build underscore Docker, then something is there. And this is basically the name of the job. Now, if you go to the job and if you click over here, then basically you will see the list of jobs. But if you look at these two jobs, run Docker image and build Docker image, all of them are having different job ID. But if you look at the pipeline ID, then you will see that these two jobs belong to the pipeline ID 5589. And you can see like which job is taking how much time to execute everything. Now, if you click on the job name, then what will you see? You'll actually see inside that what is the name of the job. Sorry, what was actually executing inside the job. So you can also see here that in the green color. So these are basically the script that I wrote in the job description in the CI file. For example, this one, for example, Docker pull, and a lot of other scripts are there. So if you click on the job name, then you will be able to see which task or which script was taking how much time and whether it is successful or not. Okay, so there is a question mark, I believe. How applicable is GitLab over GitHub, and what are the common differences on which one to use as a student or cybersecurity? Okay. I would say, I mean, there is no big difference, I would say, because in the large enterprise, if you look at sometimes the enterprise, they prefer GitHub, sometimes they prefer GitLab. Whatever it is, if you are in the GitLab, then they always prefer that all the ecosystem, all the CI/CD should be able to do. I mean, they should be able to implement that one. So the difference, if you tell me, then probably it is it's the limitations from the subscriber from the commercial point of view. When it's a large enterprise, at the time, obviously they will look at how much they are spending for all these things. For the student point of view, I would say you can try GitLab because I have not tested GitHub for the CI/CD. But what I know that, I mean, at some point, I feel GitLab is much more easy to understand, easy to write the CI file. Obviously, the CI file that you write in GitLab is different from GitHub. One big difference is that in the large enterprise, you can deploy GitLab on your own premises, which you cannot do in the GitHub. So this is one of the big differences. So what I mean by over here is that you simply download GitLab, the software itself, and if you have, as a large enterprise, if you have your private cloud, you can deploy GitLab in your private cloud. That means the piece of code, whatever you are developing, the large piece of code, whatever you are developing as a company, the code will be inside within your infrastructure. But if you go for GitHub, then definitely the infrastructure belongs to GitHub. Obviously, those are secure enough, but from the compliance point of view, you can say that our code is with us. It is not shared with any other organization, and that is the big difference between GitHub and GitLab. But as a student, I would say to go with GitLab this is pretty much easy compared to GitHub, I feel. But it could be again personal choice. Why do the two Docker images carry the same job ID? What is that? Let me see. You may unmute yourself and simply speak, and you can. Docker images carry the same job ID. What is that? Can you help me and to identify what is that? I guess it is your reference. Sorry.
Can you hear me?
Yes, I can.
Maybe he was speaking about the names. When you look at it, build Docker image, run Docker image. It seems like there are two different. There are two things that are having the same name there: build Docker image and build Docker image. The second and the last one, and also the first and the third one, they were bearing the same name. That was what I think he was asking.
Okay. So are you saying that build Docker image over here 9141 and build Docker image 9139? Is that?
Yeah, maybe that was what he was assuming. I was not the one that asked the question, but that was what I thought.
Okay.
Yes, sir.
So these
It's me asking the questions. Yeah, your previous law, the previous law, you just you can go back one more step. The previous law, you got 88
so
37.
what is
The
the
previous
slide
law.
number?
Yeah, no, go for next.
What
Next.
is the slide number? Can you tell me the slide number?
No, I didn't copy this. Just go nurse. I think it's around, yeah, right here. Yeah, right here. Right here.
Two
You
Docker images having the same ID. Okay, now can you point out which
you
one?
got no, go nurse. Now yeah, I think it's around 16. Yeah, somewhere around here. No, I think that's it. Go nurse again. Go nurse. Yeah, right here. No, go back. Previous line. Yeah, right there. No, go back. No, go back.
Yeah, I was there.
No, previous line. Go back. No,
Yeah,
you are going.
tell me the
Go back.
slide number. I
The
will go
start
there.
number is around 16. 16.
16.
Yeah,
16.
16. Go back, yes. 17. Take 17. Let's see. 17. Yeah, right here.
Yeah.
Yeah, where you got job, where you got it to run Douglas images, then you got 888A 3471D. 8834711D.
Okay, so these are.
Yeah, this it, yeah.
Okay. Okay, so this is not the job ID. Job ID is your 9142 and 9141. These are the two different job IDs. So this is your commit ID. This is not the job ID. So that means the moment you commit a new piece of code or the moment you commit the changes, then at the time, there will be some commit ID. That is something yesterday we discussed, right? So this is the commit ID. So on which commit the jobs were executed. Okay, so this is what, so from here what you can see that 9142, this is the job ID and it is executed on the commit ID 8183471D. The similar ways, the job ID 9141, it is executed on commit ID, the same commit ID 81834. So if you look at also the timing, so if you look at the order, then you will see for this commit ID, there was a pipeline 5589, and inside that pipeline, there are like two different jobs. And the first job is 9141, and the second job is 9142. So this is not the Docker image ID, rather this is the commit ID. You got it?
Yes. Understand.
Great. Okay. So also I would point out over here that whenever you have any question, I would it would be great if you can simply point out the slide number. Just note down the slide number and then just tell me the slide number. It would be easy to navigate. So, okay, next. Now here the question arises that where do you define the whole pipeline? So if you look at the whole pipeline, again, you need to create this YML file, which should be in the root directory of your project, of your repository. And this configuration file, so this basically contains the CI/CD configuration. And the example, one of the example is over here. There is something in the previous slides we saw. But now let's discuss each and every keywords. But because it is very essential for you to know, first of all, that how to construct this pipeline. So if you look at over here, so these are the jobs. So for example, over here, build Docker image, this is one job. Run Docker image, this is another job. And this is basically, these are basically the scripts. So one after another, your runner will execute each and every command. So first, all the scripts are grouped into one job. And also you mentioned this job will execute in which stage. And all the stages, the order of execution of those stages will be defined inside the stages keyword. And then you have which one? Yeah. Then you have inside the job, in addition to the script, there will be something called before script, and there will be something called after script. So it doesn't matter whether you write before script before actually the script or not, where you write, it doesn't matter. But if you write something before script, and inside before script, if you write any command, those commands will execute first, and then the commands inside the script will execute, and then after that the commands inside the the commands inside the after script will be executed. And give me a second. Yeah, sorry. So similar to your script, there will be before script and after script, and the scripts inside those will execute. So before script will execute first, and then script, and then after script will execute. That is also called cache. So it is to specify a list of files or directories to cache between the jobs. So usually what happens that whatever the output of your one job, it will not be transmitted or it will not be shared with the with any other jobs. So once if you're running the second job, and during that time the output of first job is not available, will not be available unless you explicitly mention to preserve or to store the artifacts or to store the output of one job as the artifacts or in a cache format. So cache, it's simply, it will store the output of one job. And also you can mention that when actually to define this one. So for example, on success or on failure. So if a job failed, then the output should be stored just to debug why the job failed. And if it is on success, you can simply ignore that one. In addition to that, also there like tags are there. So you see over here, probably in the first job you have one tag, and tag is built. For the second one, there is something, of course, in the screenshot it is not there. So usually what happened that in the larger system you have a number of different several commits are there, right? Very frequently it's coming to the main repositories. But at the same time, the runners, it could be possible that you have different runners out there. Maybe one runner is installed in your CentOS environment. Maybe another runner is installed in Windows environment. Maybe another runner is installed in macOS environment. So for your commit, you mention in the CI file that this job should be executed by the runner which is inside the macOS environment. So that means when you have multiple number of runners are available, you can choose that which job should be executed by which runner. And for that, you have tags are there. And definitely, when you install the runner, at that time, you need to say that the runner should pick the jobs with very specific tags. So the other keywords are allow failure. So this is what previously I was saying that inside one job, so inside one stage, if any one of the jobs failed, then the runner will not move on to the next job or to the next stage. But if you say allow failure is true, that means the job can fail, and in that case also the runner will move on to the next stage. And artifacts is again this is the list of files and the directories to attach um, uh, to a job on success. So for example, over here, let us say if you're generating any files or if you're generating any configurations or any other kind of artifacts, those things you can store inside the GitLab environment. So what happened over here, if you are generating any file, that file will, or a report, that report will be stored inside the GitLab. And later on, you can move on and you can see what is the artifact and what is the report. And this is sometimes necessary when you are testing your code. So for example, if you want to know what is the code quality of your application. So code quality will basically tell you whether the code is having proper syntax, whether it is having proper alignment, whether it is having proper organization, whether it is having proper naming convention. So the code quality may generate a report by testing all or by scanning through all the codes, and for that you might implement a code quality inside one job, and definitely that code quality will generate some report. So when you generate the report, at the time that report should go to the GitLab server and it will be stored inside that. So that in later on you can refer that one, or you can check whether the report is good or not. Custom variable. Okay, so now like different variables are there. One is the custom variable. So for example, in the CI file itself, at the top you will write inside variables, you will write what is the variable name and what is the value of that variable. So that is what your custom variable. Also, you can have some variables. You can mention that one inside your GitLab, not in the CI file, but in the GitLab itself. And that will be again password protected. So if you go to your GitLab, you open the project, you go to the setting, and then you go to your CI/CD, then you will be able to see variables. And that variable you define what is the key and what is the variable name and what is the value. And you can say whether it is a password or not. If it is a password, then obviously the value will not be displayed. And this variable, you can use that one inside your CI file. Okay, so these are the two different types of, or there are two different ways you can define your own variable. Okay, now the other type of variable is the predefined variable. We'll see in the demo time that what are the different types of, oh, sorry, what are the different predefined variables available. For example, CI commit reference name, or CI commit ID, or you can see some predefined variable. For example, like what is the commit ID, who is the author of the commit, um, and when the commit was made. All those things will be available as the predefined variable. But how to know what the different predefined variables available? For that, you can simply write inside the script env environment. Env stands for environment, and that env will basically print all the variables, and you can look at that. So over here, okay, so here we have mentioned some of the list of predefined variables. You can go to the official document to see again further the list of predefined variables. So for example, what is the job ID, what is the job name, what is the who is the commit branch, what is the commit branch, what is the commit author, who is the commit author, what is the description, what is the message, what is the pipeline ID, and a lot of other predefined variables are available. Now, GitLab registry. I guess this is what we discussed before, that it's nothing but it's very similar to the Docker Hub. So in the Docker Hub, what you are doing is you containerize your application, and then you publish your Docker image by sending that one to the Docker Hub account, right? So instead of doing that in GitLab, you can also prepare the image, and then you can publish that one, or you can store that one inside the Docker, inside the GitLab registry. So if you imagine the large enterprise where like they have the code, and whenever they will build any image, that will also be stored inside their own on-premise systems, on-premise servers. So they don't have to go to a external third-party service provider to store their Docker images, and that is something the GitLab is also providing. Package registry, infrastructure registry, those things are not, we're not discussing. Okay, so if you look at the GitLab registry, again, you open your project, and then over your packages and registry, you will be able to see what is the container registry. And when you click over here, then you will be able to see what the different Docker images are there, in addition to, along with the tag of that Docker image. Okay, so basic containerization command. So for that, so by default in the Docker, what you do, you simply log in and you provide your username password, and that will be by default, it will be pushed to the Docker Hub. By default, it will be public also, unless you make it private. But if you want the Docker images to be pushed to the GitLab registry, at the time, you just need to log in to your domain. So wherever the GitLab is installed, you provide that domain. Obviously, once the GitLab is installed inside your private cloud, the GitLab will basically show you what is the command, how to log in, how to build, and how to push the Docker images. And this is an example. Okay. Okay. Again, this is the example of how what is the naming convention. So, for example, over here, if you log in, so Docker login GitLab dot and then your domain name. So before it was like if it is not GitLab, then the command was simply Docker and login, nothing else. And if there is no other parameters provided, no other values provided, then it will simply log into the Docker Hub. Okay. So before we are discussing what is GitLab Runner, right? So as we discussed before, that GitLab Runner is nothing but a small piece of code software tool which will execute all the commands that you have written inside the script or inside your CI file, right? But how to install this one and how GitLab Runner will detect this one? So this is kind of a little bit of advanced concept, that how GitLab Runner knows that you have committed some code or some changes in the GitLab remote registry. So just imagine that maybe your runner, that small software tool, is installed in a different laptop, let us say, and you are editing or you are developing the code from a different laptop. So the moment you commit the changes and it is pushed to the remote repository, then automatically the runner will be or the runner will get to know that there is a new commit, and the runner will automatically bring that new piece of code and it will do, or it will execute the CI scripts. So the GitLab Runner is, again, it's a simply a open source which is written in Go language, and it can be run in as a single binary. It can be, you can run this one inside a Docker container, or you can deploy that one inside a Kubernetes cluster. Kubernetes, this is something in the next session we'll discuss. But when we say that GitLab, when you add something to the GitLab CI file, GitLab detects it and an application called GitLab Runner runs the script. But how GitLab basically detects this one? So before that, if you want to see the list of runners, then you simply again go to your project and go to the setting, and inside setting you'll see CI/CD, and then you will see the runners somewhere over here, and then you need to expand the runners, and then you will be able to see. Of course, the interface is slightly different than different from this what is mentioned in the screenshot, but in the demo time you will see. Yeah. So GitLab Runner again is a sorry. Okay. So the GitLab Runner again, it is a worker machine which executes the project's GitLab CI jobs through work stealing. So what is work stealing? So work stealing is simply a concept where the runner will always ask the GitLab server that if there is any job pending, please assign that one to me, if it is for me. So GitLab runner basically send the request to the GitLab instance. So basically your gitlab.com, or if the GitLab is installed inside your cloud, inside your private cloud, then that is those GitLab instance is something over here, the GitLab server. And it will ask if there is any pending job, and if there is, then it will simply ask to assign the jobs to itself. So the runner can be, it can be a specific, it can be a group, it could be a shared. If it is specific, that means the runner will execute the CI file that is present inside your project only. But if it is a group, then in the GitLab, usually you create the group, and then inside the group, you create multiple different projects. So you can create a runner which is available to all the projects inside the specific group. It can also be the shared. So if it is a shared, it is basically available to all the projects, to all the groups, and it's basically created by the GitLab server administrator. And then over here, when you create a GitLab runner, at the time you need to provide what is the executor. So executor is basically it defines how the GitLab runs, how the GitLab runner basically executes the job using which executor. It could be shell, it could be SSH, it could be Docker. For example, like if you are confused with executor, then let me give you an example. So if I say make mkdir make directory, then where actually you will run this one? You will run that one definitely in the command prompt, not in the cell terminal, right? Because that command will be executed by your command prompt cmd. But if you say the command is let us say ls command, you cannot execute the ls command in a command prompt. You need to execute that one in the cell terminal, right? So definitely uh, these are different different tools, different executors. Your cell is one executor, your docker is one executor, cell basically your bash, or it could be assets simply, and those are different different executors are there. So what is the execution flow if you look at? So usually what happens, you have the GitLab runner, you have the GitLab server where your code is present. You have GitLab runner. It could be inside your virtual machine, it could be inside your laptop, or it could be inside your production server. And then there is an executor. The executor could be Docker, it could be command prompt, it could be PowerShell, it could be Bash terminal, it could be SS terminal. So at the very beginning, you basically create, install GitLab runner, and then you register that one with the GitLab server. So once you register that one, then in a loop, the GitLab runner will always send a request to the GitLab server asking what are the different jobs available to me. And if there is a job available, then GitLab server will basically assign that job to the runner. Now runner will go through each and every script or each and every command present inside the script keyword, and those commands will be executed using the executor provided executor. So the executor, it could be your cell. If it is a cell executor, then definitely the command should be accordingly written. So so this is again, if you have a GitLab runner, the software is installed on your laptop, you can create multiple runners, or you can register with multiple runners. So for example, like this is a configuration file. All the list of runners and their configurations are present inside this config.yoml. We'll discuss again in the demo time where actually it is. Okay, so these are some of the advanced feature or advanced concept that how frequently the GitLab runners will communicate with the GitLab server. So in your laptop, if you have two different GitLab runners already registered with gitlab.com, the server, main server, then how frequently these runners will communicate with the server and asking for the pending jobs. So let me show you some demo. Let me share that one. Give me a second. Let me share my console. Okay, let me go to my GitLab. So here what I have is, okay, so this is the repository in GitLab. So usually if you go to your profile, then you will see the list of groups and activity groups and projects. So if I go to my profile, I can go to the groups, or I can see simply the projects. Okay. So this is the project I have, and in the left hand side, what you will have is you have, for example, your build. So inside build, you will find pipelines. If you click on pipelines, then you'll see these are some of the pipelines. Yesterday, I was just checking this one. And then in each pipeline, there are like multiple stages are there. So if you look at on the status, the pipeline, okay. Yeah. So this is your pipeline ID, 18685178852. So remember this, I'm using the gitlab.com service, right? So over here, the pipeline ID is 18685178825. So 852. This is another pipeline ID. This is another pipeline ID. This is another pipeline ID. For each pipeline ID, there are different stages are there. You can also check what is the total duration for the pipeline. Total duration taken by all the stages, all the jobs, when actually it was executed, on which commit the pipeline activated, and this pipeline created by whom, who is the author of this one, for the different stages, build, then test, then deploy. So these are some of the stages we have. So if you click on any one of the pipeline, let us say I click on the pipeline ID, the most recent one, then
Excuse
you'll
me,
see, okay, yeah.
sir. I was asking that you were telling that job ID has 14 characters, but now here it is showing 10.
Job ID is not usually don't have the 40 characters length. That's the commit ID is having the 40 characters length. But obviously over here, you will not see the full ID of the commit. For example, over here, 65AD09CD. So this is the commit ID, but this is not the actual commit ID. So if I click over there, still it is not showing. It will not show you all the whole 40 characters. Rather, it will show you only the few characters. So job ID. So in the screenshot, what I was showing, the job ID is usually it was having like 4 characters length, sorry, 4 digit length, but it differs. Sometimes it could be even more. Sometimes it could be very little, because say if you install GitLab on your server, let us say if you have a server and then you started using that server one day back, obviously your job ID will be probably 1, 2, 3, 4, something like that. So since I have hosted my code in the gitlab.com, definitely in the gitlab.com, they will have a lot of different pipelines, a lot of different jobs will be there. So I hope it's understandable. Is it clear, or there is
Yes,
any
sir.
confusion? Okay. So, okay, let me go to the pipelines. So when I click on the pipeline, I'll see that, okay, there are like 3 different stages out there. And if you click on the jobs, then you'll just see what are the different jobs, whether it is, what is the status, whether it is passed, cancelled, failed, what is the job ID, and job name. And then you'll see what is the commit, on which commit the job was executed. So you'll see all the job, so all the commit IDs are same. So stage, if you look at deploy, test, build, these are different stages out there. Now, if you click on any one job ID, let us see what will happen. So this is actually the output of that job, the terminal you will see. So in the job itself, probably my first was echo deploying the application. So this is the command. I wrote that one inside the script. And then this is the output deploying the application. Then I wrote the command ls. Then it was showing me the output of ls. Then I said cd, then some folder, and then obviously there is no output for this command. Now for Docker build, this is the command. You remember, like yesterday we were using this one to build the Docker image, and then it will show me what is the output of this one. And accordingly, like all the commands, it will execute one after another in this stage. So this is the job. And obviously, if you look at the other side, over here you'll see duration, how many seconds or how many minutes the whole job took. Then timeout from the project, no runner. Okay, so this is the runner. So you will see runner is 478138007. If you note down this one, definitely later on you will get to know that there is a runner somewhere. We installed that one, and that runner is actually executing this job. Now inside this job, I don't have any artifacts, and that's the reason you don't see any artifacts over here. But if you click over here and then you go to the other job, let us say build, and in build you will have build job. And inside build job, okay, so these are like very few commands were there. Only one command was there inside the job. And if you look at the runner, again you'll see that 478138007. So this is the same runner. The same runner was executing all the jobs. Now if you click on, instead of pipeline, if you click on the jobs, then definitely you will see a lot of jobs. Some are failed, some are passed. Now if you click on any one of the failed job, probably you will be able to debug why the job failed. So over here you will see running with GitLab runner. On this is the project name. This is the some ID of that runner. Sorry, I guess this is the commit ID. See, I guess this is the commit ID. And then using the cell PWSH. So this is something it was expecting. And somewhere it was saying that, so if you look at using cell executor, and within bracket it was looking for PWSH. Now if you go to a different job, let me go to a different job. So let us say some past one. If you see it at the top, using cell PowerShell executor. So you can see the difference. Over here it was looking for PowerShell, and over here it was looking for PWSH. Now I can show you another example. Possibly, I'm not sure if this one is different or same. Okay, so this is also PWSH. But anyway, so these are the different executors are there. Now you know what is the pipeline, what is the job, and if you go to, sorry, now if you go to the setting, go to setting and then you go to CI/CD. So in the CI/CD, if you click on runners, then here you will see the list of runners. So first one is the project runner. So in the project runner, you'll see the green signal is basically saying that the runner is active, and you can assign some job to this runner. And if you look at 478138007, so this is the same runner which is executing all the jobs. For example, over here 478138007. So this is also the runner ID. So this one. Now, if you again click over here, the runner, then you will see some very important information. What is the description, last contact? Here you will see the tag. So when you have a number of runners out there, and you have only one job to execute, then any one of the runner may pick that job, right? But if you want the job to be explicitly executed by a very specific runner, at the time you can use tags. So in the job, you can mention that this one should be executed by the runner with the tags deploy. And then this runner will basically pick that job and it will execute the job. This runner also, if you click on the jobs, then you will be able to see that this runner already executed all these different jobs. Job, what is the project, what is the commit. So these are the commit IDs, and then when it finished, what is the duration, queued, and the tags. So here you saw what is the different runners are available. Now, if you want to create a runner, you simply create a project runner. Sorry, I forgot to mention others. So this is the project specific runner, and there must be something called group specific runners. So I don't have any runner inside this group runners. Yeah, and then there are something called instance runner. So these are actually also called the shared runner. These runners are available to all the groups and projects, and usually these are created by gitlab.com. So that company or that um, the engineer over there, they will basically create this instance runner for us. So here you can see the like 4, 5, 6, 7, 8, and few others runners are available. Okay, now if you want to create your own runner, you simply go to create project runner, and then you specifically provide some tag. You can provide some description, and then if you leave everything to its default, go to create runners. And then what I want to do is I want to create a runner on my laptop. So I'll create, my laptop is having Windows operating system. So I'll go to Windows, and then it is basically giving me the command how to register the runner. But before that, it is assumed that you have already installed GitLab runner. So for that, if you want to install GitLab runner download, you can download the GitLab runner. Just download and install the GitLab runner. What you need to do is once you download, it will download something called GitLab runner installer.exe file. Just double click, install like any other one. Yeah, install like any other one. And then what I did is that I have already created that one. Yeah, so GitLab runner is over here. Always keep in mind that you need to execute this one in PowerShell with some elevated privilege. So here what I have already installed. So what I'll do, GitLab, sorry, let me. GitLab runner status. So here you will see that runtime platform, and here probably if you see, okay, runner, and let me look at the list. Okay, so if you look at the list, so you will see that the number of runners I have registered with the GitLab. And this exe file is in my C drive. Let me go there. C GitLab runner. So over here, when you install from here and you basically start it, it will automatically create this config.toml file. Config.toml file. Now, if you open this one, then over here you will see executor is shell and shell is PowerShell. So if it is the Linux based probably I can write over here BASS, or I can simply write simply SS, but the most popular one would be the BSS. Since I'm in Windows, I'll write here PowerShell and then simply save it. But how to generate this one? So once you install, you register that one with your GitLab.com. And when you register at the time, what you do, GitLab register. Okay, so here it is asking to enter GitLab instance URL. So by default, it is the GitLab.com. Why? Okay. For register, actually, we need to execute this command for the registration process. So if you execute this one, let us say copy, and then what I'll do, paste it. So over here, it is mentioned already what is the URL, what is the token, everything is mentioned. So now it will ask you enter the GitLab instance URL. So by default, it will take this one, leave it as it is, verifying the runner is valid. Now enter the name of the runner. So the name is CICD.demo. Then here you need to provide the executor. So executor, it could be instance, it could be parallel, it could be Docker. For us, the most basic one is shell, SHELL. So runner is successful, registered successful. Now, once you register there, then here somehow like you will see over here that it is already registered. Sorry, your runner is created. I guess sometimes it also provide here the runner. Let's go and see the runners. Stay on the page. Okay, if you stay on the page, okay. So now here you will see that you have registered. Sorry, you have registered a new runner. Sometimes it takes a little bit of time to appear this one automatically, but the step 3 is very optional. So when I registered my previous runner at the time, I didn't use this command. So what I did is that I just wait for a few more minutes, and then it automatically it will tell you that a runner is registered with us. Now, if you click on the view runners, then you will see that before it was like one runner was there. Now I have like another runner 478208854. So this is a new runner, and the tag is Git. Over here, the tag is deploy. Okay. So now let's look at the CI file. Let's quickly look at the CI file. I have 5 minutes. So what I'll do, I'll go to my code repository. Okay. So in GitLab, what you have is if you click on the edit, then you will have the web IDE. So basically, it is similar to your Visual Studio Code, but you don't have to download the code onto your local system. Rather, the same interface you will get in the web interface, in the web form. So here I have the CI file. So I hope it is visual enough. So here you'll see that in the CI file, which is in the root directory of the project, I have different stages. And these are the different jobs, build job, and this one will run inside build. Obviously, if you run this one inside run, then this job will run inside a stage name called run, but this stage is not mentioned over here. So obviously it will throw some error. It may. So instead of that, you can put whatever the name you want. So the name of the stages is not fixed. It's up to you how you decide what name you decide. but the order will matter because accordingly your jobs will be executed. So what I have over here is that, let us say I remove all the stages and I have only one stage, that is deploy job. And let me remove this one. So the deploy job is here, deploy job, and it's execute in the deploy stage. Take is deploy. That means I have two runners, right? So out of those two runners, the deploy runner will basically execute this job. So what I do is that yesterday, the Flask application, I kept that one inside this folder, 2/docker. Okay, there are like two questions. Okay. So yesterday I created one Flask application, that is I kept inside this Docker, and the Flask application is over here. And if you look at this application, app.py file is over here. Docker file, this is something yesterday we checked. So what I'll do is, let us say, yeah, app.py, hello from Flask in Docker. We are demonstrating CI/CD with GitLab. Okay, so Docker file is also here. So yesterday, all the code were on my laptop, and we were building it, we were testing it, and then we are running it, right? So now what we'll do, we modified this one, everything, and in the CI file, what I'll do, I'll mention that go to this directory. So, and inside this directory, build the Docker app, and then run the Docker for the image you have created, run that one. And let us say, give a different name, CI/CD, and let us say the port number is 5005. And so I made two changes, right? One is app.py, hello from Flask, and let us say over here. Okay, now I will commit this one. So inside the web ID, I can commit. So I commit this one. Now you'll see that it is already saved. Now, if I go to my repository, so here you can see, okay, daemon. So here you can see the pipeline is already automatically executed. It started already. So if I go to pipeline, build and pipeline, or you can simply also click over here to see. So this is the pipeline. And if I click over here, then you'll see that deploy phase is currently going on. If you click over here, then you will see what the different commands it is executing. The job has not yet started. Let's wait. Yeah, it is started. And at the same time, I will show you. Okay. So here you can see the Docker build is going on. Docker PS. Now, Flask Docker app CI/CD. The container is created, and currently it is running. And it is running with the port number 5005. Now let's go and check it out. Localhost 5005. Oh, sorry. We are demonstrating CI/CD with GitLab. So here, what I demonstrated over here, that I modified the changes in the code repository itself. And the moment I changed something, automatically it is the respective Docker image is built and the Docker container is created. That means the application is deployed, and this is deployed on my local system. So on my local system also, I I installed it in GitLab runner. So you can see how it is a continuous process. The moment you make any changes to the code, it will reflect directly to the container, sorry, to the deployed, to the production environment. So what I can do over here, what later I can do over here is that in the CI file, I can basically remove the existing container, and then I will create a new container, and that is having the same port number. So right now I cannot do this one again because one container is running and I cannot use the same port number, right? So in a production like environment, for the best
Chinmay
practice,
sir, you also ask them to do the same thing after the class so that they can ask the doubt in the second session.
yeah, sure.
So otherwise they are not going to learn if you are going to see.
Yeah, this is basically the last step over here, the demonstration. So here, what the best practice is that you remove the previous container, and then you create the new container with the new piece of information or with the new changes in the code, right? So this is what the CI/CD with your GitLab. From the security point of view, someone may ask that how are you going to manage the passwords or the sensitive informations? For that, usually you'll have, if you go to the settings, CI/CD, you'll have the variables. So those variables you can provide over here. That what kind of variable you want to provide. You can provide some API keys. Of course, in the larger enterprise, there is a connection, the integration with some credential provider. So that is another way of integrating or securely deploying something. Okay. So this is what your CI/CD with GitLab, your continuous integration and continuous deployment with GitLab. Okay, seems there are like 2 questions, I guess. Okay. So if you have any question, you can ask, and in the later stage, the next session we'll discuss what we'll discuss. In the next session, we'll discuss container orchestration. We'll understand what is orchestration, and we will also understand what is Kubernetes. Okay. So if you have any question, just let me know, or if you can ask me later. I will share this piece of code with you so that you can also try that one by yourself.
Okay, Chinmay sir. At 12 o'clock again we'll meet.
Okay. See you then. Thank you.